Pen is done.
Ready?
Yeah.
All right.
Are we each going to do one? Why am I the only one in the video?
Oh, I just moved back.
Yeah, you got to be in the video with me.
Yeah, I would like to be in this video. I'd like proof that I was here with
Yeah,
you.
just not your booming voice in the background. All right.
So you want to go first? I'll go first. So
you go first. And then if I say I had it, I'll say ditto.
All right. So I wrote that students were all working.
Okay. I didn't write that one down.
There were multiple approaches in the class.
I got more specific with that one.
Let's hear it.
I said students are using reasoning about numbers versus procedures for solving. So there wasn't a lot of like solving procedures.
Right.
There was a lot of just like kids using mathematical reasoning to like, and some of them were like using guess and check. Some of them did like the first step of a procedure and then went straight to reasoning. Right. There was like, I would say there were those like three approaches, like kids who had underlying fluency, Drake, Ruben, Milo, all of their papers had just straight procedures because they had like internal fluencies. Then there was like this middle pocket of kids that had the first like step of a procedure and then just had like reasoning. So like Cherie was like that. He did the first step of a procedure and then he went straight to reasoning.
Great. That was my next thought on that one. What about what Ruben and Milo did would have been helpful for Cherie?
So that's where I put, at the beginning, the teacher attempted to model thinking instead of a process. And then I put like kids were fluidly moving through the problems. I think it would have been helpful had she like had everyone work on problem one and then scaffolded up like a kid who just did reasoning, a kid did a procedure plus a reasoning, all the way to a kid that then did a straight procedure and had them share and then said like, how are these connected?
So for me, I have that one here. We can put we both agree, and I wrote targeted skill. So that skill there, it was a great opportunity to target it, and she attempted to, but she left it as an option. So she had an annotation that she wanted students to write on their paper so they know how to move through these problems, and it was a suggestion.
That they write Yeah, I think that like where
Cherie struggled with the suggestion, I think he would have gotten there, and the same thing for Elijah. Elijah was like, I don't get it.
Yeah, I think when you say a skill though, where it's getting stuck in like the conversation with teachers is like that isn't a math skill, right? It's like not like it's like different than literacy, right? It's I'm like trying to figure out how to explain this. Like she needs to scaffold up the complexity of the problem solving process.
I hear that.
Yeah.
But right now there's enough students
that need the middle step.
That I think she mandates it, and like if it was a suggestion that you have on the board, then it's worth students actually getting into the habit of copying it down.
Oh, the questions. The two questions she went around and checked for, or like what do you want?
There was a guide on the board, like on how to approach responding to these questions. If it's this, then this. If it's this, then this. And she said, it's on the board. I want everybody to copy it down.
Oh, those 2 questions.
Not the questions. It was like something that they're supposed to write in the corner. And it was like an approach on how to do this. And I think I should have taken a picture of it. I didn't. But
I think that's where they're getting stuck, right? Like I'm noticing this sticking point, which I'm like trying to field through with the math people, that like the way the resource is written, problems aren't stacked in like a process, right? Like if we looked at those 4 problems, they all had very different processes.
But one process is the same, and is how do you find n? And is
the problem is though if they have this.
Yep. The first problem was n squared plus 4 equals 404.
The minute they have this, the process is different. It's actually make it equal to 0. This one is make it equal to n squared.
And this one is
make it equal to n squared.
Right. So for 1 and 2, like these processes are the same, and the fact that they had many different approaches, like Cherie knew what he needed to do, but we couldn't tell that. Right. So he had Cherie's was a math thing. Elijah's was not a math thing. He was misunderstanding the process.
Yeah, and I like this is where
for these 2, my suggestion here, and tell me if this is not it, but for problems like this, just having students say there's multiplication, the opposite of that is division. So when you see it, you divide.
Here's where we get sticky. This one?
Yeah. No, but like let's look at these 2. Like if there's a different problem on there that it doesn't work for, that's fine. But for these 2,
yeah. See, but here's where I'm gonna get stuck, and here's where the kids are gonna get stuck. These 2, like let's say this is, I can even like make this look like this. The processes are actually different.
Let's hear it.
So like this one, they should subtract the 9. It'd be n plus 2 times n minus 2. This one, they should subtract the 4 and square root it. Or 20. So like at first glance, almost looks identical.
Right.
The process to solve is completely different.
So in this one, they subtract the 9 from both sides, right?
And this one, yeah, but...
In this one, they subtract the 4 from both. That's the same. Like, if they get...
But it's not, because this one is, like, about making it equal to 0, and this one is about making it equal to the number, so you can square root. So, like...
But in the way I learned it, maybe I'm just like, oh, you combine, like, terms, or is a way I've heard it, like, because this is a whole number and this is a whole number.
But this is a whole number and this is a whole number.
And that's what you did here and here, right?
But it's where you're subtracting it to that they're getting stuck. So this is like I'm moving everything to the right side, and this is I'm moving everything to the left side to make it equal to 0.
Okay. If they did it the other way around, what would the answer be? I don't know.
They would only get 2, and they wouldn't get -2.
They would only get 2?
Yeah.
How do they know?
Right. So that's where that's why they're getting stuck. This is why teachers are getting stuck.
No, but how do you know that is the right move for them?
How do I know? So the real answer is, and what we should really teach kids, and this is where I'm like stuck with their process, is anytime n squared's in the equation, we should make it equal to 0 and then factor. Because then
then it's always right?
Then it's always right. 100% of the time it's right.
So you can solve this problem this way and it still comes out for it.
Yep. Because here, when they square root it, then they have to talk about when they get 2 answers and when they get 1 answer.
Okay, so
that's really where she's, like, where we're actually off, is, like, I think we misunderstand quadratics.
So now
it's way messy.
No, it's not. I think it's super clean now because now we have a rule that we can give to students. There's other ways to find this. This is the safe way.
This is the safe way.
Part of aggressive monitoring is so we get a targeted skill, right? And so I had one idea of a targeted skill. You have a completely different one. I actually agree that yours is much stronger than mine.
I'm trying to think about her other one.
But part of aggressive monitoring is also to be able to collect data.
Yep.
So real-time data. I saw 5 students with the right answer initially for number 1.
Initially, yeah. We had a lot of kids with the misconception of 2n versus n squared.
Yep. So you gave a lot of feedback. I gave some feedback.
Yeah.
Because because I could actually solve this one at that time. It wasn't your calc class. So I gave some feedback. And what would you have done after you went Cherie, Elijah?
So the teacher process that I want to focus on is the pullback.
Yes.
And then the scaffold up of share out.
Yes.
So like first have not Cherie, the new girl, I can't remember her name. She was catty corner. Alea had a great just complete math reasoning.
Yes.
She did not have any like solving skill, but she was able to reason through and get the answer.
Yep.
Cherie had a medium. I would have made him share in the middle. That would have made him, and then I would have scaffolded to like a Milo.
Great.
And so that's where so then is the feedback for Clayton. So this is where in my head, it is more important that she understands how to sequence, because that's what they call, so in the math curriculum, in the IM curriculum, those like moments in their lessons that they're calling like cool downs or debriefs or mid-lesson synthesis, that's where she's supposed to be flexing into that skill of scaffolding the share out. In my push with her, I would push that direction more than I'd push aggressive monitoring, because if she can scaffold that share out, then whether or not she checked on their paper, like she's going to move that class. This is where we get stuck with the aggressive monitoring feedback.
How did she get to that point without aggressive monitoring? Like, if she's not going around and she doesn't know exactly what students are doing, how does she know it's time to do a whole class pullout? That's why I push aggressive monitoring.
What is she going to check? Like, in our idea of having a key, though, for aggressive monitoring.
She could literally do what she's doing. You get a star if it's correct, which I don't think is the best. But what it does is it showed me that there's a missed opportunity, like she didn't recognize in the moment. Like, when I see I gave 3 stars after 10 kids, it's time to stop, pull back. And so, like, 5 kids with a misunderstanding, stop the show. That's what I'm looking for. Like, a trigger to say, when do I stop the show, pull back, and come back whole group? Also, here's what else I noticed.
I'm trying to think about through this.
And
keep going.
When we initially entered the room, we saw her she was checking the work. And she called on 3 students that did not have the answer, and she ended up giving them the answer.
I put that.
If she was aggressively monitoring, she would have known which students she could have selected to give. So it's not always about marking the paper. It's about...
I think that's what they're getting lost. I think that their concept of aggressive monitoring is like, I mark the paper. I think in math, the framework we need them to use is like, what level of complexity is this kid solving with?
First, I hear you, and that's the right direction. But
I think that if they're just marking the paper, we're not.
No, but marking the paper now says you're going around marking the paper. That's a plus. Now, what data are you collecting and how are you using it, which then goes here. The
problem is, what are they marking the paper for? The correct answer or the correct processes?
They have to decide. They're content experts, and you can help them decide. What I want for math specifically to do, they need to know where students are and how to correct it, because we saw students move on from the process of the first side of the page to the second side of the page and continue. I didn't see any increase in the number of students who were immediately solving problem number 1.
I think she needs to sequence and have a discussion. I think that
How does she know that she needs to sequence and have a discussion?
Well, so I think that like in our monitoring, we need to monitor for sequence.
There you go.
But that's not marking the paper. I would push that I don't want them to start with marking the paper, because where they're stuck right now is they don't know how to mark the paper, because it's both accuracy and process at the same time, and it's just like too much for them in their heads, because they're like, well, if I'm monitoring for accuracy, then if they used a reasoning strategy, they technically got it right, so I should mark them right. But then I don't want them to think that is always right, because that reasoning strategy worked that time, but that's not a procedure. Do you see where they're getting stuck?
So for every math problem, is there like a safe way and a random way to get an answer?
For every math problem, yeah.
Which one should we teach?
We should teach reasoning with procedures.
Right.
The problem is we should allow kids that can get answers right with reasoning to continue to do that until it breaks, and then like pick them up there.
I don't see any problem in that, but like, for questions number 4 and 7, I'm coming around looking for your procedures. The other questions we can solve through your reason if that's your strong suit. But you say for these three, you target 2 questions and say, for this one, I'm checking to see if you can show me this skill that I just taught you. So, like, you're not taking away their ability to do the other thing. And, like, you can tell them, if you want to solve it your way, fine. And then show me you can solve it this way, fine. And then we'll move on. And if a student says, well, I only use it.
But that's in contradiction with how their resource is written. Like, that is in direct contradiction with how IM wants them to do the work and how IM is pushing them to do the work. So, like, this is where they're getting stuck, and this is why I'm going to push, is, like, that's it. So they are not supposed to teach a procedure first. They are supposed to allow a kid to reason through it.
Right.
So then aggressive monitoring wouldn't be appropriate all the time. It'd be appropriate on the cool down.
So, okay, so then that's where it happens.
Okay.
On the cool down, but...
They need to know how to aggressively monitor for sequencing.
Aggressively monitor for sequence. On the cool down, they have
a key.
A key with the procedural lock.
Yep. Because, like, the sequencing is building the procedure.
Should they be aggressively monitoring during the do now?
Yeah.
Should they be aggressively monitoring before the cool
They should be
down?
aggressively monitoring all the time.
There we go.
But what they mark on the paper is different.
Well, and, like, again, like...
That's where they're getting stuck, though.
I'm not telling people to aggressively monitor everything all the time. I'm saying to target a skill and some content and monitor for those 2 things. So, like, I think that's what... I don't think
that's what you're telling them, but I don't think that's what they're hearing. I think what they're hearing is, like, you want them to
walk around marking the paper all the
time. And then what's happening is they're losing this, like, beautiful moment to sequence. And I think what I need to work with them on is, like, how do you aggressively monitor to build your sequence?
I have a ELA video of that. I would like in your next coaching meeting with your math teachers, you have them aggressively monitor for sequence and show a break it down when they go high, medium, low in their sequencing.
You want me to film them or show them a video of someone?
I want you to film. I want you to coach them how to get there.
Yeah.
And then I want you to film them or
doing it. Yeah.
Or they, because I think having math teachers show that, oh, we can do this and it is working. It's coming from you with your math terms is going to be way more powerful than.
Yeah, I think I need to teach. I think, like, the number one skill I noticed in that classroom was she needs to know how to identify the sequence that kids share. Because they're not all engaged in that discussion. And then the discussion fell flat. And then once the discussion fell flat and she moved on to the next part, she tried to give them this framework to, like, think about the other questions, but because they weren't all involved and they didn't see their solutions represented in the discussion, Elijah was like, I don't understand any of this. And I was like, that's not true. You're just not connecting. And that's back to, like, how kids are sharing in the sequencing.
So after a sequence,
you have a discussion. And then you've sequenced to sharing in the discussion.
I go sequence, discussion, stamp the learning.
Yep.
You have them write it down.
Yep.
And do a quick check for understanding. You go low, medium.
So, because, like, the sequence in this would have been, like, if we take this problem and we sequenced it, we would have started with our friend that would have said, well, I just kind of thought about it. And I said, well, this plus this is 404, so... 20 squared, da-da-da. And then Cherie's like, oh, I subtracted 4, and then I knew I had n squared equaled 400, and I thought to myself, what times what is 400?
And he thought 20 times 20 was
400.
Which is fine.
No, he thought 200 times 200 was 400.
200 was 200, yeah, it was 400.
And that gets at this misconception, the 2n versus n squared. And then you have, like, a Milo share, which, like, had an actual mathematical process. And then you say... Right? And then you go, okay, how are these 3 connected? And kids can say, well, they all got to the thing and they all thought about, like, subtracting, and which one captures all the thinking? Oh, this series of steps captures all the thinking. Great. So this is why we, like, write it, right? And then you can
have them copy it down.
Yeah.
All right. I would have them all copy this down so you get used to seeing this procedure, and then you can duplicate it the next time you see it. Because I saw some people turning back to the first page, trying to remember what they saw on the board, but they didn't copy it down. That was the 2 in the back corner.
I think the thing that makes it so hard is it's, like, discovery, like, they're trying to marry inquiry-based learning with, like, developing skills, and it's just so hard of a marriage. It's just a really hard, like, the math curriculum is just requiring a really sophisticated set of skills.
I love inquiry-based learning, and
I do too.
I do think there's, like, a place where the 2
I think there's a marriage.
There's a place where
I think the teacher skill for the marriage is so sophisticated.
And that's where we come in. So, like, I now that we're in the habit, some people are begrudgingly, aggressively monitoring. They're going around, like, super low level, I'm going to put a star. What we saw a lot of last year were monitoring people thought was just kind of monitoring for behavior. We walked around the classroom. This year, like, she putting a star on paper so she knows, like, this student got it right, this student got it right. She didn't have a seating chart. So, like, I think when you start putting stars or checks or circles on a seating chart, you get to say, well, I just walked by 10 students and I have only 5 stars. Like, I need to stop.
I want to push the math people to aggressively monitor on a seating chart before they aggressively monitor on the kid paper.
As long as they're collecting data, like, they will start to see trends. Like, I think what we both did in there, which we want the teacher to do, is we walked around and we noticed trends. Mm-hmm. So we did that without marking student papers.
Yeah.
I do think that students...
I think kids benefit, but I think that not until we make the math learning, like, transparent for them, that, like, we are building from sense making to being able to generalize and apply patterns. Like, until that's clear to kids that that's actually what's happening, and we can say to them, I'm going to mark, if you're solving this using sense making, I'm going to put a check.
Right.
If you're solving this using half sense making and half generalizing, I'm going to put a 2.
Yep.
And if you're solving this using generalizing, I'm going to put a 3. But until that arc is really clear, the monitoring feedback for kids is, like, really random in math class. It's either all accuracy or it's all process.
But what's wrong with that annotation guide you just came up with?
I just came up with it. that's the problem. I haven't, like, fleshed that out.
That's what we do, right?
Yeah,
we build.
Right, like, I think
the iron sharp as iron. We got there. That's great.
Sense making, and then the top is generalization.
And it's transparent. You're naming it for students. They know what they're getting.
And then the middle one is, like, the half and half. And then that would let them know that's what they need. Because then she would know that's my sequencing. I start with a kid that's just making sense. I get a half and half kid. In between each kid, I ask the question, how are these connected? And then once we have the generalization, we stamp it. I used to call that in my room. What do we know to be true about math? That was the stamp.
Come up with a cool acronym for
Truth about math.
Truth about math.
Math is the truth-telling subject.
All right, so I'm going to be Miss Clayton.
You're going to be Miss Clayton?
Yeah.
Okay.
In our coaching meeting. And hopefully...
You're going to be as funny as Miss Clayton?
I'll try.
Do you want me to just do the name it and then...
To do it.
You want
the name it and then to do it.
The name it and then the do it.
So once we name it,
okay,
we'll move forward.
I don't have to do. Am I doing the question part where I ask you to reflect about your lesson and?
Sure.
Oh, that part feels funny.
Let's do it.
Okay.
I was there, so I know.
Okay, I gotta, like, reposition my, like, different seeing. Yeah, see, we're both kind of. It's really just the computer.
Yeah, it's just computer coaching. Okay.
We're computer coaching. All right. Hey, Miss Clayton.
Hey, Miss Reynolds. How are you?
Good. How are things with you?
Things are good. A lot of wholesome moments.
Yep. In your class, I want you to take a minute and think about that lesson. I noticed you working really hard, and there's kids working really hard. I just want to say, like, I appreciate that.
Thanks.
When you were aggressively monitoring, talk to me about what you noticed and how that felt.
I was doing all the things Clarke said. I was walking around. I had an exemplar, and I was putting stars on the correct answers.
How'd that feel?
I was, like, frantic. Like, I got around to a bunch of students, and I saw some students with misconceptions, but a couple students got it right.
Yeah.
Questions 1 and 2.
How are you noticing, like, that marriage between what you're looking for and what you're monitoring for?
I think I'm, like, just checking for correct answers, and I'm not able to really help students who are processing differently.
Yeah, you named it. Like, I noticed that too. And I started with Mr. Clarke to really reflect about how we're aggressively monitoring. And I know that you and I have constantly been talking about this tension that we're feeling between, like, what are we monitoring for? And, like, Mr. Clarke really helped me codify this thought that I want to share with you. And then I want to see, like, if we can think about it.
Oh, great. I've been really struggling for trying to make everybody
I
happy.
know. You and Martha have had a lot of... I saw Miss Via in there trying to help you aggressively monitor. Yep. We're all working as a team to try to figure this out.
Perfect.
Here's what I noticed. In math, we have, like, 3 phases of kids understanding things, right? So they have the sense-making phase. So think of, like, Cherie. He often is living in the sense-making phase. And then we have kids that are living in the generalization phase. The sense-making phase happens really, really fast for them. And then they're able to generalize that with like abstract algebra really quickly. I think that that's actually what we should be monitoring for. Is like, did you solve the problem using sense-making?
Okay.
Are you solving the problem using some sense-making and some like trying to apply a rule or procedure? Or are you solving a problem with a procedure? We're not giving value judgment on those. We're just noticing.
Got it.
Thinking about that, had you walked around that class, how would that have changed your whole class discussion if your feedback would have been around sense-making, kind of generalization, and generalization?
All right, so let's pause.
Yeah.
Let's go back and like.
I need to name those.
Yeah.
I do. I need to like name those phases.
Let's write them. Let's script them now so we can get them clean. So like.
So it's gonna be sense-making.
Sense-making.
I need a half and half. I want to call it like fun. Schmedium. Schmedium sense-making. It's not schmedium sense-making.
You can
it's
write
like
sense-making plus reasoning. Or is it?
No, those are the same. I'm trying to think about what makes it kid-friendly. Right? So the first one is like sense-making. The definition for kids is I use what I know about math.
You wrote half and half.
Yeah. Yeah.
Let's do it.
Half and half. I just have to like think of some kid-friendly language to like.
And then this one is
generalizations, which is like math practice standards 7 and 8, which was the really hard math practice standards to get kids to.
All right, so let's script out right now exactly what we're gonna say to Clayton in this next upcoming coaching meeting as far as how we're gonna turnkey this thought into action in the class.
So then the turnkey. This is where I struggle between coaching through questioning and coaching through telling.
You did a lot of telling there.
I know I did.
I would ask to see if she knew what 3 buckets do you like if you could put students in 3 buckets in that class as far as how they approach equations. Solving.
Yeah.
There you go. So
the nice thing with this is this will work with anything.
Yeah. So like let's do this. Let's.
So the question for Clayton would be. We have lunch in 10 minutes.
Yep.
And then we name it. And then we would build it.
Yeah. All right. So let's.
And then we practice it. All right. Can I talk you through what I'm thinking?
Yes.
All right. So I think my inquiry-based question for Hillary would be, what math practices did you notice in student solving processes? Right? And then she would say, well, I noticed that a lot of kids were using math practice 1, which is students can make sense of problems. She talks a lot about the math practices. And then she would say, I would notice that some kids were doing like a mix. And then some kids got to 7 and 8, which is the generalization one. I go, great. How might we use that for monitoring?
Before that, I would have her name those.
Just make sure it's like named right there.
Name those because we're gonna.
Yep. Okay. So move that up there, and then how might we use that for monitoring? I think she'd get that. I think she'd get there. I think I could like. And then what is the benefit? I like that question. I like them to name why it's important, both for them, because the thing I want her to get for her is like, for the kids, right? They know what level of sophistication they're in for mathematics, which is an important like
self-assessment.
Yeah, an important illumination of math for her is knowing that gives her a sequencing. That is like the on-ramp to sequencing, is if I can name the sophistication of solving, I can then sequence student shares and discussion. The minute she can do that, and then we would like grab a lesson and we'd build it, and then we'd practice it.
When's your coaching meeting with her?
Tuesday.
Tuesday. Perfect.
Yeah. Do you want me to film it?
Yes.
Great.
And then let's see if we can film her
doing it. Great.
So like
I'll set that up.
Set aside. Yep. A day you're gonna film the coaching meeting, then you're gonna film the.
Yeah, she knows we're filming the next coaching meeting, so.
Then we'll have an English, a history, and a math one in our Olympus database for aggressive monitoring.
Oh, sounds good.
Yep.
Great, I like it. This helped codify for me what aggressive monitoring means in math.
It helped me actually just name like that frustration. I think when people come to PD, they're
spiraling.
They're trying to participate, and they're saying that there's a tension between, the skill set for, humanities and between math.
Yeah, because the skill set for humanities is almost the concept set for math. Like the skill set for math is like I can add, subtract, multiply, and divide.
Mm-hmm.
And then the level they're at now is like the depth of thinking. And that is like, there's just this misalignment with terms. Like skill in math means something different than I think skill in humanity. And so every time they hear skill, they're thinking like, they want us to check for multiplication. I'm like, no, that's not.
I will call that fluency.
Right. That's it's so messy.
Yeah. I would call that math fluency.
Yeah, I put that for Hillary.
Skills.
I need to bring her some numeracy fluency scaffolds.
At Uncommon, we use this thing called, and this is in the middle school, arrows.
I've seen some arrow stuff, yeah.
AEROS. There might be something else in there. And what it was students would annotate this on their paper first, and then for every page of math, they would have these kind of cheat sheets that they memorized over time and they would write. And what it did was it allowed them to go through these processes. How do I approach certain problems? So like a problem like this, they would say, there's an equal sign. I have to get everything to 0 on one side. And they would name that every time like with a certain mark. So
yeah, that is like